Okay. So what we're going to start off with is basically a review from Algebra 1. I shouldn't be teaching you anything today that you don't already know. Okay? None of this is really Algebra 2. But if we've forgotten, that's what today's for. Okay? So we start by looking at these parent functions. Okay? And if you think about what a parent is just like where you come from, right? So a parent function is just the function that all other functions originate from. Okay? And we're going to start off with this one called the constant function. Does anybody know what a constant is? Something that never changes? How about a number? Number, yeah, stays the same forever, right? And the only thing that does that is a number, right? So a constant could be like 4, -8, could be 2/3, okay? So for our purposes, we're going to write f of x, which means the function of x is equal to c. And c is going to stand for any constant, okay? So that could be 4, 8, -2, could change, okay? But to put it on the graph, we're going to make an example. So for example, we're going to have f of x equals 4. So I'm just giving c a number for this. I'm just saying it's 4. So what that means is that x, whatever x is, my y, or my f of x, is always going to be 4. So if I go on my y-axis and I find 4, and I want to find a way to illustrate that no matter what, my y value is always going to be 4, well, when x is 1, y is 4. When x is 2, y is 4. And you kind of see what's going to happen here? When x is 3, y is 4. What kind of line am I generating? Just this horizontal line, right? It's constant. It never changes. It's just this flat, constant line. So that's what it looks like. Okay? It's a horizontal line, basically. And then down here, D and R are going to stand for domain and range. Okay? And domain is just a way to say the set of all possible values of x. So if we think about what x values we can have in this line, we just kind of ask ourselves some questions like, do I have positive x's? Do we have positive x's? Yeah, because x is moving to the right, right? Do I have negative x's? Yes. Do I have decimal x's? Technically, yeah, right? I didn't specifically graph them, but I have billions of little points here, so I do. So basically I'm saying x can be any number in the whole world, right? Well, what's the math phrase for that? All real numbers. Y'all remember that? And when you were in Algebra 1, it was perfectly okay to write the phrase all real numbers. We don't do that. We have to write it the fancy way, okay? And I'm going to give you two ways. I'm going to give you the longer way first. This is a curly brace. It's a set brace. That means the set of all x such that x is an element of all real numbers. And that little element is basically a capital E but rounded. And that is an R with two stems. And that is a closed brace. And that translates to the set of x's such that x is an element of all real numbers. Or you could just write an R with two stems, and that symbol literally translates to the set of all real numbers. Okay? We just can't write out the phrase, if that makes sense. All right, and then for range, we're going to look at this and see what kind of y values we have. Okay? So we ask ourselves kind of the same question. Can I have positive y values? Can I have negative y values? Can I have decimal y values? Well, what do you notice about every y value this entire line? Yeah. What is it? 4. So no matter what, y is just 4 in this example, right? Generally speaking, I just made up 4 as an example, but generally speaking, it would just be whatever c was, right? So our range would just be c. But for our example, for this specific example, it would be 4. Ooh, that was a bad set brace, sorry. I'm out of practice. But we need these little braces. Don't overlook those because that translates into a set. It's kind of like a room where all your answers live, right? And you need the set braces to tell us that that's the room where the answers are, basically. Okay? Okay, so this next one is the one you're probably more familiar with, the identity function, which means, you know, y is equal to x. So f of x equals x. They're the same. Whatever x is, y is also that. So if x is 0, what is y? 0, because they equal each other, right? If x is 2, what is y? 2. So I'm going to go 2, 2. If x is 4, y is 4. And I'm just going by 2 so I don't plot every single point, just to kind of speed us up. And you can kind of get how this is going, right? 6, y is 6. X is 8, y is 8. And that goes for the negative side too, right? X is negative 2, y is negative 2. Negative 4, 4, 6. And you can kind of fill that out. And if you're wondering why you have to pick up a ruler, it's because we need to make sure our lines are straight. Okay, here we go. We have our line. Okay. All right, we look at this one and we want to figure out its domain and range. If I think about its domain, what are the values of x that are here? Is this one also all real numbers? Positive? Yes. Negative? Yes. Everything in between? Yes. So yeah, it's all real numbers. What about our range? Positive? Yes. Negative? Yes. Everything in between? Yes. So this is also all real numbers. Okay? And pretty much all lines are like this, except for our special one, the constant function. Okay, now we're going to look at some things like our slope and y-intercept. Okay, so review of how you find slope. Something over something is slope. What are those something? Change in y over change in x. Yep, there's a couple more sayings you know for slope. Change in y over change in x. Rise over run. Anything else? Yeah, that's where we're leading to, exactly. We put it all together to mx plus b, exactly. So yeah, change in y over change in x, rise over run. So if I look at this one, and I graphed by 2s basically, but if I look at my rise, which is how much I go up or down from point to point, I'm going up 2, and I'm going right 2. Well, rise is 2, over run is 2, and what is 2 over 2 reduced to? 1. So our slope of this we would say is 1. And then our y-intercept, that's where the graph crosses the y-axis. Well, that would just be right here, which is at 0. I'll write the whole point, 0, 0. Okay? And when we take these things and we put them together, we can create this slope-intercept form, y equals mx plus b, which basically just says in a y equals equation, the coefficient or the number in front of x is your slope, and the number added or subtracted is the y-intercept. So there's an invisible 1 in front of that x, right? And then we really just have plus 0 at the end. Okay? So real quick, how we graph in slope-intercept form. Well, you know what slope-intercept form if you have a y equals equation, right? First thing they do is they look at the y-intercept. So this has a plus 2, which means the y-intercept is 0, 2. That's where this point comes from right here. Then we look at the m to determine the slope, and that m is 3. So that means our slope is 3 over 1. If there's ever not a bottom to that fraction, there's always a 1 there. So they go up 3 and right 1. And then we see that we ran out of room. So to continue, they just do the opposite. Instead of up and right, they went down 3 and left 1. And that's what generated these other points. Okay? And that's where this line came from. Now the thing to remember is, if your slope is positive, when you do your rise, you're going to go up. Positive slope, you rise upward, which logically makes sense, right? If it's a negative slope, your rise is going to go down, so you're going to count down if it's a negative slope. But you're always, no matter what, when you run, you're going to go to the right, no matter what. The only time you switch that up is when you run out of room moving to the right, then you just swap everything and do its opposite, okay? All right, so I'm going to give you some time to, like, just a few minutes to try 1, 2, and 3, okay? I'll come by and help you if you need it, and then I'm going to show you the answers, okay? Because I don't want to talk at you this whole time. Okay, here are your, this should be the answers to those first 3. Okay, so just if I didn't get to answer your question, just kind of check to see if you have what I have. I think that maybe one of the most common things is this one on number 3, the negative slope. Remember, negative slope means you're going to go down in your rise, but you always move to the right. The reason for that is down is a negative direction and left is a negative direction. If you do 2 negative directions, what do you now have? Positive, right? So we're only going to move in one of the negative directions, so we're going to go down. Okay? Any other questions about this one before we move on? Okay, let's do point slope form. Okay? That's the next thing. Okay, point slope form, this one requires that you kind of memorize a little formula. This guy right here. Okay? That, you're going to have to memorize that, okay? And we like this form because it actually gives us within the equation a point to start from. We don't have to start at the y-intercept. So x1 and y1 are going to be replaced with actual numbers. And this x and y just stay x and y. And what is m? The slope, right? Universal variable for slope, okay? So what you need to remember is that these minus signs are part of this formula. They're not indicative of the number that x1 and y1 are. They're part of the formula. So that kind of makes it tricky when we figure out what they are. So for instance, here's our example, right? All right, if I want to decide what's that point we're starting to graph, I look up here for the x value. So this number is going to give me the x. And I see that this number is in its place. But look, there's a plus sign. And there's a minus sign in the formula. Anyone know what that means about this number, for there to be a plus right there? If the formula says it should be a minus sign, but I see a plus sign, what do I know about this number? Yeah, it was a negative, because it would have said x minus negative 1. Well, if ever I see minus negative in math, we always want to go to it and go, ugh, right? 2 negatives make a positive, right? So whenever you see a plus, that means that this number is actually negative. And whenever I see a minus, well, that minus is really just part of the formula, right? Sound confusing? A little bit, maybe? Here's what you just remember. These numbers right here are always going to be the opposite of what they look like within the equation. Get rid of this little random plus sign here. Okay? If you just remember that, then this becomes a little bit easier. Okay? So if I want to graph this, I look at the x, that's this one. It looks like a plus 1, well, it's really a negative 1. And then I look at the y value. It looks like a negative 2, but it's really a 2. So that's where they started first. They started at negative 1, 2, and they plotted that point. And then they used the slope of 3, which is right here, and they made more points. So up 3, right 1. Ran out of room, go down 3, left 1, and so on. Right? Okay. All right. So what I want you to do is try that. I'm gonna start you off a little bit with number 4. Let's all get the correct point and the slope. Okay. So if I want to know the point that I'm starting with, first I find its x. Anyone know what number that is? What's the x value of that number? Is it 2 or is it negative 2? It's 2. because it's opposite the way it kind of looks in the equation. So my point is going to be 2, comma, what? 3. Opposite the way it looks. And then my m, my slope, is going to be 1/2. So that means to graph this one, I'm going to start at that point, 2, 3. That's the point 2, 3, right? X comma y. And then from that point, I graph my slope. That's a positive 1/2, so I go up 1, right 2, point. I ran out of room, so I go down 1, left 2, point. Down 1, left 2, point. And now I have my line. Okay? All right, now you all try 5 and 6, and I'll come by and help you. And then I'll show you the correct answers. Okay, so that's what we have there. Okay, so we should have, they're opposite in the point, but the slope's not opposite, right? The slope is what it is. Right? And did everyone catch in number 6, since there was no number with your y, that no one's really going to write y minus 0 because it's kind of redundant, right? So that's why the point was 1, 0, and our slope was negative 2 over 3, so we went down to right 3. Okay? Any questions on the point slope form? Just something you have to remember, right, about this opposite stuff. Okay? Okay, one more form. Standard form. Okay? The pretty form that doesn't really give us a whole lot of information until now. So when you were in Algebra 1, and everybody was in that class at some point and took the STAR test, right? And the STAR test was littered with equations that looked like this, right? And your teacher probably made you rewrite this so that it looked like slope-intercept, y equals. So you could put it in the calculator, right? Maybe, remember? Okay, and that totally works, but there's an easier way to graph something like this by using intercepts, okay? If you realize that an x-intercept is just the point where the y is 0, and the y-intercept is just the point where x is 0, that makes finding some key points pretty easy here. So if they want to find the x-intercept, they're just going to put y as 0. And what happens when you multiply anything by 0? It's 0. It basically disappears, right? So even a shortcut further from this is, if I want to find the x-intercept, so my y is 0, can't I just cover it up? Look at the equation I'm looking at when I cover up the y term. I'm looking at 2x equals 6. Can I solve that really easily? Divide by 2? What's 6 divided by 2? 3. X-intercept is 3, 0. So they plotted it here, right? And you can do the same for the y-intercept. The y-intercept is just where x equals 0. Well, plugging in 0 for x just pretty much makes the x term go away. And I'm looking at a positive 3, y equals 6. Divide by 3, what's y? 2. So our y-intercept is 0, 2. And then we have those. Take the ruler, draw a line. Okay? So I'll try that once with you with number 7. So if I want to use that method, right, I want to use that strategy to graph this, and I want to find the x-intercept, well, that means the y is 0, right? So I know right away it's going to be something comma 0, because the y is 0. To figure out that something, I just cover up the y term. And I'm just literally staring at the answer. The answer is x equals 3, right? So our x-intercept would be 3, 0. And our y-intercept would be very similar, right? I would just cover up the x, so the x would be 0, and I want to find the y. 3y equals 3. Y is what? Divide by 3. 1. 0, 1, right? 3 divided by 3 is 1. So all we do is plot those points. X-intercept of 3. Y-intercept of 1, and we have a line. Okay, not so bad. Okay, I want you to try number 8 and try 9. Yes, something weird happens in 9, but go as far as you can with it, and we'll talk about it in a minute. Okay? You want to see number 9? Okay, so x-intercept for this one would be 3, 0, and this one would be 0, negative 2. I think I did see, I don't think I caught it when I was walking by. Sometimes it's hard to see that tiny paper. That should be a negative 2 because when I cover this up, that negative sign sticks with that 3. So 6 divided by negative 3 is negative 2. So 3, 0, 0, negative 2. That's our line. Okay. Okay. Now number 9, here's the deal with number 9. If you go to do your x-intercept, what happens? Anyone see it? 3x equals 8. Well, what's x? If I cover up the y, I have 3x equals 8, right? Can I divide 8 by 3? No. So our x-intercept is 8/3. And it is 8/3. It's not a decimal, and it's not a mixed number. Mixed numbers are for recipes. We're not baking cookies, right? So it's okay to leave it as 8/3. I know that's awkward, but it's okay. If I do the y-intercept, cover up the x term, because that's a 0, right? So 0 for x, and our y is what? 4. Okay, so that one's easy to graph. 8/3. Well, look, think of it this way. What if that number were 9/3? What's 9/3?
3.
9 divided by 3 is 3, right? So this is 9/3. So 8/3 is just 1/3 before it. So it's like ish about here, right? All right, now if we don't really like being that not precise, we can do what we did when you were a freshman, right? Where you took this equation, 3x plus 2y equals 8, and you can get this in slope-intercept form, right? You'd move the x term on the other side. You remember that? You'd subtract it. It'd go on the other side. Maybe I'm not showing it the way your Algebra 1 teacher did, but this is essentially the same. This is what you did. So on this side we have negative 3x plus 8. And then we divide by 2. So y equals negative 3 over 2x plus 4. And look, there's our y-intercept of 4. But now this gives us a slope, something we can actually count, right? So if we were to graph it this way, this would be down 3, right 2, point. Down 3, right 2. And that does kind of put our x-intercept in the right place, doesn't it? Okay. So sometimes you're going to have an intercept that might be kind of gross. Then just do it like you did in Algebra 1. Get it in y equals. These are just strategies for you, and you are welcome to use the intercept strategy, or you can rewrite everything in slope-intercept form. It's up to you. Okay? All right, the last thing are just the two special case lines, all right? It's not really a form, they're just special cases. If I write this down, does this look like something you might understand? Yeah, if you were a freshman here, I'm sure you did. I'm sure they made you do a whole little foldable thing on that, right? Hoivux. Horizontal lines have a 0 slope and they are y equals a number. Vertical lines have an undefined slope. They are x equals a number. Okay? So if you have a y equals, you plot the y-intercept horizontal line. If you have an x equals, you plot the x-intercept vertical line. So if I have x equals 3, horizontal or vertical? Vertical, that's Vux. So x-intercept of 3, vertical line. Okay. Y equals negative 2. Horizontal or vertical? What do we think? Horizontal. It's constant function, right? What we started the day with, constant function. So y-intercept and a horizontal line. And y equals 1/2 is also horizontal. It's just kind of not on a perfect point, okay? Okay. So, here's what I want you to do now. There's this section called Now You Try, and they're all kind of scattered. They're all examples that have something to do with this entire notes, okay? I want you to take about 6 minutes and do some of them. I wouldn't do the ones that you know you can do. Like if you know you can do 13, maybe spend your time doing something else. Because for the next 6 minutes, I can help you, okay? And then after that, I'll show you the answers so you can kind of check the rest for yourself. Okay? All right, so do what you can in the next like 6-ish minutes. I'm actually going to do 17 quickly. All right, so maybe you figured out that, okay, well first make sure you caught that these points were opposite. That point should be -4, 3 that you plot, right? Everyone catch that? And then your slope is a +2, okay? Maybe you got in, maybe you understood that in number 16 you had to divide everything by 4 to make that look like slope-intercept form, and then it graphed nicely. But when you got to 17, this isn't any form at all. So what I would do is move the 4 to the other side, so it looks like x minus 3y equals -4. And now that's standard form, right? And I can get an x-intercept. I have an x-intercept of -4. But the y-intercept's kind of ugly, right? So our y-intercept is 4/3, and I really, really, really don't want to graph 4/3. But if I figure out the slope, I can get the rest of that, right? So if I figure out the slope, all I have to do is move the x on the other side. We're not done quite yet, because I'm guessing most of us didn't get this, so let's make sure we are with us for this part. -x minus 4, because I moved the x on the other side, and then I can divide by -3. So I have y equals, what happens when I have negative over a negative? Positive. And instead of writing x over 3, I'm going to write that as 1/3 x, and then plus 4/3. Now again, I know that that's an ugly y-intercept, but at least I know the slope. I know the slope is 1/3, so I can go up 1, right 3. Up 1, right 3. Up 1, right 3, and there we go. Okay? That one was the trickiest one on there, but you want to have it down correct in your notes so you have something to look back on later. All right, now you're going to take your little glue stick that you picked up when you walked in. You're going to put some glue on the back, which is blank. Yep, every day you come in, whatever's on that table you need. So just make a habit of grabbing whatever it is on that table, okay? And there you go. Notes that are legal for you to use on the quiz, okay? The homework paper, you want to make sure that's done by Friday, okay? That's on the calendar, but I'm just like hinting that to you now as well, okay? And what's due Thursday? The prereq paper, yes, huh? No, that's your notebook is yours. You keep it with you. I would pass around